Tonight, you will press your fingertip against something without thinking about it. You have done it thousands of times. A phone screen, a glass, a door handle, a sheet of paper. Each time, you leave behind a signature. Not your name, not your DNA. A pattern that began before you were born. Long before your first breath, your fingerprints already existed. They have survived every birthday, every injury that never reached the deepest layer of your skin, every place you have ever touched. And no one else has the same pattern, not even an identical twin. That sounds impossible. Identical twins share nearly all of their DNA. So why don't they share fingerprints? The answer begins inside the womb. Around the 10th week of pregnancy, tiny ridges begin forming on a fetus's fingertips. At first, they look almost identical from one developing hand to another. Then, something unexpected happens. The growing skin experiences tiny differences in pressure. The fetus shifts position. Amniotic fluid moves. Blood vessels branch beneath the skin. Even microscopic changes in growth speed alter the final pattern. Scientists call this developmental noise. It is randomness layered onto biology. Genes build the foundation. Chance finishes the design. By about the 24th week of pregnancy, the pattern is complete. It will remain remarkably stable for the rest of your life. That makes fingerprints something extraordinary. They are shaped by both nature and chance. Could anyone predict your fingerprints before you were born? Not with today's science. Researchers can explain how ridges develop. They cannot predict every tiny wrinkle. Mathematician and biologist Alan Turing proposed that simple biological systems could produce surprisingly complex natural patterns. His work helped inspire later research into how structures like skin ridges emerge during development. A tiny difference can spread across an entire fingertip. Small beginnings create permanent outcomes. Your fingers are living evidence. But why do humans have these ridges at all? For centuries, people guessed they existed simply to improve grip. That idea seems obvious. Yet experiments tell a more interesting story. Studies by researchers such as Roland Enos suggest fingerprints may not dramatically increase grip on dry objects. Instead, the ridges help regulate contact with surfaces. They channel moisture away. They improve friction under many conditions. They also make touch more sensitive. When your fingertip slides across a surface, the ridges create tiny vibrations. Those vibrations travel to specialized nerve endings beneath your skin. Your brain transforms them into detailed information about texture. Without realizing it, you can distinguish smooth glass from rough stone in a fraction of a second. You are not simply touching the world. Your fingertips are constantly reading it. Every page you turn, every keyboard you type on, every face you gently hold. Your fingerprints help your brain understand them all. That makes every fingerprint both a tool and a history book. People noticed their uniqueness thousands of years ago. Ancient civilizations sometimes pressed fingerprints into clay seals and official documents. They may not have understood biology, but they understood identity. Centuries later, fingerprints would become one of the world's most powerful methods of identification. In the 19th century, Sir Francis Galton carefully studied thousands of fingerprints. He showed that their overall patterns remained stable throughout life. He also demonstrated how astonishingly unlikely it was for two people to share exactly the same arrangement. His work transformed fingerprint identification from curiosity into science. Soon, police departments around the world began building fingerprint collections. Entire filing systems were created. Millions of cards filled with loops, whorls, and arches. Today, computers compare prints in seconds. But the principle remains unchanged. A tiny pattern on your fingertip can connect you to a single moment in history. Could fingerprints ever disappear? Not easily. The outer layer of skin constantly sheds. New cells replace old ones. Yet the deeper blueprint stays intact. Only severe damage reaching the skin's regenerative layer can permanently alter the pattern. Even then, scars become part of your unique print, rather than replacing it entirely. Your fingerprints record change without losing identity. There is another mystery. Some rare people are born without fingerprints at all. This condition, known as adermatoglyphia, is caused by specific genetic mutations. It is extremely uncommon. For those affected, everyday identification systems can become unexpectedly difficult. A feature most people never notice suddenly becomes essential. It is a reminder that ordinary biology often supports extraordinary parts of modern life. Every you,